Hello everyone, welcome to TypeScript Today. Today we're going to talk about these two types that seem very similar at first glance, but actually behave very differently. The first one is a generic type alias that happens to be a function. In the second case, we have a true generic function. Nor do I mean that this type is just a generic type alias that happens to be a function. Well, we can define other type aliases that are also generic. For example, we could create this object type that is a generic type. Result will be a generic type. We have to specify as type parameter when we use it, but it's an object type. Similarly, this type will also be a generic type, but it happens to be a function instead of an object type. Now what we have in this case, however, we have a true generic function. And we're going to see exactly what this means in a little while. So let's see what the difference between these two types is when we actually try to use them. So let's take a look first of all at the generic type. Let's say we have this type and we're trying to create a new function that allows us to save data. So we're going to declare a variable, let's call it saver. And let's try to specify save data as its type. What we're going to see is that TypeScript requires us to specify the type parameter now when we've declared the saver function. So for example, we could declare that this is a saver of person. Now when we invoke this function, well, we can only pass in persons. If we try to pass in, for example, a dog, our function is not going to work. It's going to give us an error. So this is not a generic saver. This is actually a person saver. This is the defining trait of a generic type, namely that you have to specify the type parameter when you're declaring the type. So for example, when you're declaring this variable, you have to specify the exact type of the type parameter, the concrete type. And once you've burned that type into your variable, you can't actually change it later. So this is always going to be a person saver. It can't possibly save dogs. Let's see what happens if we move this type parameter to make this signature a generic function signature. Now what we notice here is, first of all, that save data no longer accepts a type parameter. In fact, we get an error. Save data is actually not generic, because save data is not a generic type. It is a generic function, but not a generic type. So we can specify the type there. However, when we actually invoke this function, we see that that is the moment when t becomes specified. So on line 13, because we called person saver with a person, we see that t has become person. So now the parameter is of type person and the return type is a result of person. On line 14, we notice that t has become dog. And so the return type is also a result of dog. So this is the defining characteristic of a generic function. Its type parameters are specified at call site. That is the moment when they become something concrete. That is the moment when they're no longer just generic parameters. They actually gain their concrete types. Note we could also specify these types explicitly, but most of the time TypeScript does a pretty good job of inferring generic type parameters to functions for us, so that is not usually something that is required. It's also important to note that while we haven't actually called this function, the type of the return still contains this unresolved type parameter, right? So inside our function signature, we are using these type parameters. The boundary at which these type parameters gain their concrete values is the call site, right? So when interacting with this function, once we, for example, say here person saver, we're not actually passing in just a generic type t. This must actually gain a concrete type. So for example, if there's no place to infer t from, t will be unknown. But once we actually pass in something, then t is going to become whatever TypeScript was able to infer from parameters. So we can say now that this is not just a person saver, it is a true generic saver that can save any sort of data. Generic functions are useful exactly for this property, that these types are decided at call site. So each call site can have a different type parameter, and we can establish relationships between one argument that was passed in and, for example, the return type, as we do in this case. Or we could create relationships between different parameters. So for example, let's have a similar example. Let's say we have a person type, and we want to create a function that validates the fields of person, or the fields indeed of any type. So we have this validate function. It has a generic type parameter t. First of all, we're going to pass in the object we want to validate. Then we want to pass in a set of validators. These are just going to be functions for each field to validate each field of our target object. I'm not going to go into the map type that is used to accomplish this, but there is definitely a relationship between target and validators, right? Validators has to have the same keys as our target object. And the return type is also something that is going to be related to the target parameter. It's going to have the same keys as t, but it's going to have the value of each key as string or null, with string representing the error message. So now when we try to call this function, if we don't pass in anything yet, t is still object, because TypeScript couldn't infer anything, so it took the type constraint as the type parameter. If we pass in person, then t is going to become person. So here, the next object will have to have a property age, which has to be a function that performs validation. And let's say we are going to not accept values outside of range 0 to 150. But this is not enough. We also have to pass in another validator for name. And now TypeScript is satisfied that validators has respected the relationship to the target parameter. And also the return type, again, is something that will contain keys for each key in person, right? It's no longer just a generic type t, it's now concretely person, and each of these keys must be of type string or null. So we've successfully established relationships between a second parameter and the return type, all based on the type of the first parameter. And now if we were to pass in something else, for example, a dog, then the validator parameter and the return type would also be dependent on that first parameter, on the type of that first parameter. Thank you very much. I hope this was interesting. Looking forward to see you next time.